Hello everyone, welcome to Mathematics in the Modern World. Then disjunction or only false when both statements are false. In this given statements, we have two false on both statements, which is the answer become false in P or Q statements. Otherwise, if not satisfied, answers become true. Let's try and solve. In the previous videos, we talked about negation, conjunction, biconditional, disjunction, and conditional. Example number 1. Construct a truth table for negation. P implies Q in close parentheses, which P and Q are the given statements. And P implies Q and negation P implies Q are two statements of proportion to be solved. How to get P implies Q? Here's the step. First, we need to find in P statements the truth value, which is false in Q statements. To become false in P implies Q statements. This applies in conditional way. Then, in P in Q statement is true, the P implies Q become true, and so on. This is true and true. However, in reverse way, if Q implies P, which is in Q statements, need to tackle first. Example, if Q statement is true, the P statement is false. Next, conditional or logical implication. Symbolically, P implies Q, also known as F then. Results true in all cases except the case true and false. Remember, we need one true in P statements, which is in Q statements is false. If not satisfied, other answers will be true. Next, logically equality or biconditional. Symbol as if and only if. Only true if the both statements are true, and even both statements are both false will result to true. Negates to false. Then true negates to false, and false negates to true, then true negates to false. In this table computation, negation P implies Q are false, false, true, and false. This total computation results should be contingency because there is true and false value. Another example. Number 2. Construct the truth table for P conjunction not Q conjunction R. Here's the table. In P, Q, R are the variables, which is three statements or proportion are the given statements. In this statement, P conjunction not Q and P conjunction not Q conjunction R are the problem that we're going to solve. In the given question, we need to solve not Q statement first. Then proceed to P conjunction not Q and P conjunction not Q conjunction R. So the given statements are P, Q, R, which we need to look and negate in Q statement to not Q statements. Where is true the opposite of false, true to false, false to true, false to true, true to false, true to false, false to true, and false to true. After that, we need to solve P conjunction not Q. To solve this, we need to look in P statements and not Q statements, which is we need two true in both statements. If not satisfy others, other answer will be false. Then we need to proceed and solve P conjunction not Q conjunction R, which is, remember, in conjunction with, we need to find two true in both statements. So there it is, one true in P conjunction not Q and one true in R statements. Otherwise, if not satisfy, other answer will be false. The result of this compound statement is contingency, because there is a true and false value. Now we look at this set of parentheses, not P and not Q. We look them as individually, not P and not Q, before we look them as a whole. So in not P statement, we look into P statements and take an opposite of this, true to false, or negates it, to true to false to true, and false to true. And the same applies at not Q statements to Q statements, which is true to false, false, true, and true to false, and false to true. Now we all took the opposite value of the column. Okay, now we are going to solve not P and not Q at the same time. When it comes to end statements or conjunction statements way, both of the components or statements need to be true in order for a true and entire statement. Otherwise, if not satisfied, it will be false. So now, take a look in not P statements and not Q statements. We have false to false, and false to true, true to false, and finally we have two true in these statements in order to become true value in not P conjunction not Q. Now we have to take the entire statement in which we focus P or Q statements and not P or not Q statements in order to get P or Q and not P and not Q statements. Remember, in any statements of conjunction, we need two true in both statements to become true. Otherwise, if not satisfied, it will become false. So there is one true in P or Q statements and false in not P and not Q statements. So the answer will be false. True to false, then false. True to false, then false. And false to true, it will become false. Because if we have a column of all false for the statement, that makes statement a contradiction or self-contradictory. The conclusion on these both statements cannot be true at the same time.